Dear friends, in continuation with the earlier previous videos, I am going to discuss about form measurements of gear tooth profile. Spur gear, helical gear, bevel gear. It is a power transmitting element. It is one of the important mechanical component used in almost all the mechanical engineering applications, aerospace applications, toys, medical, in almost in all the fields we are finding the application of gears. Such an important element, important component of engineering gives lot of challenges and opportunities to continue our work. See, now we are looking at the gear tooth profile. It gives a lot of nomenclature, that is details about the gear tooth. If you look at this addendum circle, in the bottommost is dedendum circle. The top of is called addendum, bottom of is called dedendum. And the imaginary circle drawn in the middle is called pitch circle. You have the face width, top land, circular pitch. Kindly note the circular pitch, tooth thickness, working depth, wall depth. So these are the important terminologies being used in gear teeth profile. How we are manufacturing the gear tooth, that is entirely different. We are not bothering about manufacturing or generation of the gear teeth. We are very much concentrating on the errors caused while doing the manufacturing and measurements and tools used for measuring and how it will enhance the quality of the gear teeth profile. These are the points we are going to discuss in brief in this video. Let's move on to the next slide. The same slide. So the tooth profile, it is the shape of any side of gear tooth in its cross section. Pitch circle, already I have told, it is an imaginary circle that rolls without slipping over the circle of its meeting gear. Addendum and dedendum. Module is the ratio of pitch circle diameter to the total number of teeth. This is very important. It is a ratio of pitch circle diameter to the total number of teeth. 20, 40, 45, 66 likewise. Divided by, that is the pitch circle diameter is 300 mm divided by 44. That will give you the module. Face, as we have seen in the previous color diagram, part of the tooth in the axial plane lying between the tip circle and pitch circle. That is called face. Flank, it is a part of the tooth lying between the pitch circle and root circle. Top land, that is the top surface of the tooth. In every manufacturing, there is a possibility of errors. That is, while manufacturing, the errors may occur. While choosing the material, that is gear blank, the error may be occurring. While casting the gear blank, error may occur. While finishing, the error may occur. While matting with another gear, the matting error may occur. So there are different types of gear errors. In the beginning of the metrology, we have seen some other types of errors like sensational, random, and other types of errors with the related to the instruments. Whereas now we are discussing about gear errors. The profile error, the first one is the profile error, the maximum distance of any point on the tooth profile formed to the design profile. The difference between actual and design pitch. While doing the design work using the CAD or other software tool, there we would have arrived at one pitch, but really generating the manufacturing the gear, it will give another actual dimension. The difference is ideal and actual, that is designed and obtained, is called pitch error. Another is a cyclic error. Well, in each revolution of gear, this error occurs. Run out, this is another important error. The total range of reading of a fixed indicator with the contact points applied to the surface rotated without axial movement about a fixed axis. That is run-out error. Eccentricity, that is of the radial run-out. Wobble, run-out measured parallel to the axis of rotation at a distance from the axis. Radial run-out, axial run-out, they are the perpendicular and parallel to the axis of rotation respectively. Periodic error occur at the regular intervals. Need not give much importance for that. Okay. How we are going to measure these types of errors? Run-out. What is the run-out and how we are going to measure that run-out? Not error, run-out. It is testing the gears. The testing the gears are placed in the mantle as we are seeing the diagram, and the dial indicator of the tester possesses a special tip depending upon the module of the gear, and the tips inserted between the tooth spaces, and the gears are rotated tooth by tooth, and the variation is noted from the dial indicator. That is called run out. For each tooth it will measure and give the reading. That is run out. Pitch run out measurement, not error, it is a measurement. Pitch measurement, point to point measurement, that is one tooth point to next tooth point. This is an angular, direct angular measurement. The instrument has three tips. One is fixed measuring tip, second one is sensitive tip, whose position can be adjusted by screw, and the third tip is adjustable or guide stop. The distance between the fixed and sensitive tip is equal to base pitch of the gear. All the three tips are made in contact with the tooth by setting the instrument, and the reading on the dial indicator is the error in the base pitch. Now look at this tooth to tooth measurement. There is adjustable guide or stop, fixed measuring tip like vernier caliper jaws. Imagine that vernier caliper jaws, and screw. The screw to change the position of the adjustable stop. This is adjustable or guide stop. This is a dial indicator fixed over this. This is a body screw to adjust position of sensitive tip. This is called sensitive tip. This is called sensitive tip. This is called fixed measuring tip. This is called base pitch. The point between this and this is called base pitch. This is called tooth to tooth measurement using the dial indicator. Direct angular measurement. This is measuring the error by using set dial gauge against a tooth. In this method, the position of a suitable point and tooth is measured after the gear has been indexed by suitable angle. After indexing, we will be doing this measurement. Profile checking. There are two methods. One is optical projection, another one is invalid measuring machine. Now look at this optical projection method. The profile of the gear is projected on the screen by optical lens, and then projected value is compared with the master profile. Invalid measuring machine. This is the machine invalid measuring. This is the invalid measuring tip. The gear is held on the mantle, and the circular disc of same diameter as the base circle of the gear for the measurement is fixed on the mantle. After fixing the gear on the mantle, this is called mantle. This rod, vertical rod, is called mantle. The straight edge of the instrument is brought in contact with the base circle of the disc. The straight edge. Now the gear and the disc are rotated, and the edge moves over the disc without slip. The stylus moves over the tooth profile, and the error is indicated on the dial gauge. The stylus will move, and the error is indicated on the dial gauge. This is invalid measuring machine. Backlash is the distance through which a gear can be rotated to bring its non-working flag in contact with the teeth of matting gear. Tooth thickness measurement. As we know, gear tooth vernier, base tangent method, constant cord method, and measurement over pins or bars. So up to this we have about gear measuring and gear errors. Thank you for watching this video. Thank you.